Hello everyone, in this video we'll be solving problem 1351, count negative number in a sorted matrix. The ask is to return the total number of negative values in the grid which is sorted in non-decreasing order for both rows and columns. In example number 1, we are given a 4 by 4 grid and across the entire grid there are total of 8 numbers which are negative. The problem statement is very easy and straightforward, so let's try a couple of approaches to solve this problem. Starting with the brute force approach, we'll iterate through all of the elements in the given matrix and calculate how many of them are less than 0. Once the iteration is complete, simply return the count. As we are iterating through the entire matrix, the time complexity will be O of m into n, where m and n are the number of rows and columns. While the space complexity is O of 1, as we only need to use one variable to record the count. Although this approach solves the problem, it doesn't take into the fact that given rows and columns are already sorted. Let's think of an alternate approach where we can leverage it. If a corresponding value in a row is negative, then all of the value to its right will also be negative. This is because each row is sorted. Similarly, if a value is negative in any column, then all of the values below it within the same column should be negative. Based on that logic, if I know the first element in a given row is negative, I can easily calculate the remaining elements by comparing the current position and the total number of elements. I don't need to iterate through the remaining elements to get the count. I can take the current position and subtract it from the total elements in the given row to tell me how many elements are going to be negative in the corresponding row. The same logic applies to the column as well. If I know a particular value is negative in a given column, I can easily take its current position and subtract it from the total elements in the given column to get the remaining negative elements. Now based on that logic, let's come up with a solution to solve this problem. We start the loop from the bottom left element of the grid. Is it negative? Yes, it is. So we calculate the total number of elements in the row that will be negative, which is the difference between the total rows minus the current position. In this case, it is 4 minus 0, so total will be 4, and it will be added to the result variable. As we calculate it for the entire row, we'll shift upwards by decrementing the row counter. We'll repeat the same process. The value is 1, which is not negative, so we'll go inside the no condition, where we'll shift towards the right to see is the next element a negative value. In other words, we are incrementing the column pointer. As the next number is also positive, the same steps will be repeated, where we'll increment the column pointer. The next value is minus 1, which is negative, so we'll go inside the yes flow, where we'll calculate the total number of elements to its right, including itself. Total elements are 4 and the current position is 2. The result is 2, which will be added to the global count. Like before, we'll decrement the row pointer to look at the next value above it. This will continue until either of the row or the column pointer goes out of bounds. With this solution, our time complexity is improved to O of m plus n, where m and n are the number of rows and columns in the given grid. This approach no longer requires us to iterate through all of the elements in the given matrix. And the space complexity is O of 1, as we are only using a couple of pointers, one to record the count and the other to record the current column and row values. I hope this was helpful. Let's walk through its Python implementation. In this Python implementation, I start by initializing a couple of variables to record the total number of rows and columns and the count variable to record the output. After that, I am starting a while loop to iterate through all of the elements until the row and column pointers are not out of bounds. Inside the while loop, I am first checking if the value that both row and column pointers are pointing is it negative. If yes, then I am calculating the remaining elements to the right hand side of the current value and adding it to the count variable. Next step is to decrement the row pointer by 1 so that we can try the next row right above it. If the number is positive, then we go inside the else condition where we increment the column pointer by 1 so that we can shift towards the right and check the next element. This code when submitted on LeetCode beats 100% of the submissions in terms of runtime and nearly 7% in terms of memory. Thank you for watching this video. I hope you are able to understand the explanation. The details to access the source code is available in the description below. Feel free to check that out and I will see you in the next one. Thank you.